Supermassive black holes are not just simple holes in space. They are incredibly dense regions where gravity is overwhelmingly strong. So strong, in fact, that nothing, not even light, can escape its pull once it crosses a boundary called the event horizon. These cosmic behemoths reside at the centers of most large galaxies, including our own Milky Way, which hosts Sagittarius A*. These fascinating objects can possess masses equivalent to millions or sometimes even billions of our Sun. They are true titans of the cosmos, playing a crucial, though not yet fully understood role in the evolution and structure of the galaxies they inhabit, influencing everything around them. Our attention now turns to a specific galaxy, known by its catalog name SDSS 1335+0728. This galaxy is located at a considerable distance from us, approximately 300 million light-years away, nestled within the constellation Virgo. At the heart of this distant galaxy lies a supermassive black hole. This particular black hole is estimated to have a mass about 1 million times that of our Sun. For a significant period, roughly 2 decades, this cosmic giant remained in a quiescent state. It was largely dormant, showing very little activity that our Earth-based and space telescopes could detect, like a sleeping monster awaiting a cosmic alarm clock. Then, quite dramatically, something began to change. In the latter part of 2019, astronomers using the Zwicky Transient Facility, a project designed to scan the sky for fleeting cosmic events, detected an unexpected shift. The galaxy SDSS 1335+0728 suddenly started to increase in brightness. This was not a minor fluctuation, it was a very noticeable and significant surge in its overall luminosity. This abrupt brightening served as the first compelling indication. It strongly suggested that the dormant giant at the galaxy's core might be stirring from its extended slumber, possibly heralding a new era of energetic activity and providing a rare spectacle for scientists. Paula Sanchez-Saez, a key researcher from the European Southern Observatory, ESO in Germany, vividly described the astonishing nature of this event. She stated, "Imagine you've been observing a distant galaxy for years, and it always seemed calm and inactive. Then she continued, quite unexpectedly, its core starts showing dramatic changes in brightness. These observed changes were, in her words, unlike any typical event we've seen before. This powerful statement underscores the unique and surprising character of this particular black hole's awakening, marking it as a truly remarkable and significant observation for the entire astronomical community worldwide." The awakening of the black hole in SDSS 1335+0728 was not an instantaneous flash, but rather a developing process that unfolded over time. Initially, the central region of the galaxy began to radiate with newfound intensity. This emerging light was observed across a broad range of the electromagnetic spectrum. Astronomers detected intense emissions in infrared wavelengths, which often signifies heated dust. Simultaneously, strong signals appeared in optical light, the very light that our human eyes are sensitive to, making the galaxy visibly brighter. Furthermore, a significant outpouring of ultraviolet radiation was also recorded emanating from the galactic center, indicating very energetic processes were now underway. The celestial light show did not stop there. It continued to evolve and reveal more about the underlying physics. By February of 2024, a new and crucial type of signal began to emerge from the galaxy's core. The black hole started emitting X-rays. X-rays are a form of very high-energy light. They are typically produced in environments where matter is heated to millions of degrees, often associated with some of the most extreme and violent phenomena in the universe. This detection of X-rays was a critical piece of the puzzle. It strongly confirmed that the black hole was not merely passively glowing but had become intensely active and dynamic. So what exactly was causing this dramatic transformation? The supermassive black hole had begun to actively feed. These cosmic giants grow by gravitationally capturing and pulling in nearby gas, dust, and even unfortunate stars. As this material spirals inexorably inwards towards the black hole, it forms an accretion disk and heats up to incredibly high temperatures due to friction and compression. This superheated material then radiates enormous amounts of energy across the spectrum. This process was visibly transforming the galaxy SDSS 1335+0728. It was clearly developing what astronomers call an active galactic nucleus, or AGN, a hallmark of a feeding supermassive black hole. The immense scientific importance of this event cannot be overstated. It stems from the fact that we are witnessing this transformation happen in real time. Astronomers have long held theories and models describing how supermassive black holes can switch between active and dormant states. However, this is the very first instance where we have been able to observe a black hole making this precise transition. We are literally watching it shift from a quiescent, or quiet state, to a full-fledged active one. This provides an unprecedented opportunity to test our existing models and gain direct insights into this fundamental, yet rarely seen cosmic process. The activity emanating from this newly awakened black hole, affectionately nicknamed Ansky by some scientists, has shown remarkable persistence. Ansky has now remained in an active state for a continuous period of 4 years, ever since its initial brightening was first detected in late 2019. This prolonged duration of heightened activity is a point of great interest and study for researchers. Many other types of cosmic events that cause a sudden increase in brightness, such as the explosive deaths of massive stars known as supernovae, tend to be much more short-lived. Ansky's enduring glow strongly suggests a more fundamental, long-term change is occurring. Let us place Ansky's behavior in context by comparing it to other luminous cosmic phenomena. Its current level of brightness is indeed significant and noteworthy. The activity has been far more sustained than the flares associated with typical supernovae, which might shine intensely for several weeks or perhaps a few months before fading away. Ansky, in contrast, has maintained its brilliance for years. However, it is also important to note that its overall luminosity is still observed to be lower than that of quasars. Quasars are the most dazzlingly bright and powerful types of active galactic nuclei known, often outshining their entire host galaxies. Ansky may represent a different class of AGN. Scientists are diligently exploring various explanations for Ansky's unusual and sustained activity. One initial hypothesis considered was that we might be observing a tidal disruption event, or TDE. A TDE occurs when an unfortunate star ventures too close to a supermassive black hole. The immense tidal forces exerted by the black hole can stretch and tear the star apart in a cataclysmic process. This stellar shredding event releases a brilliant burst of light. However, typical TDEs generally reach peak brightness and then fade away relatively quickly, usually within a span of a few months. Ansky's persistent luminosity over several years makes it an outlier for a standard TDE. This groundbreaking discovery and ongoing study of Ansky are the fruits of a significant international collaborative effort. Researchers from around the globe are meticulously analyzing data collected from a diverse array of telescopes and observatories. This multi-wavelength approach allows them to study Ansky across the entire electromagnetic spectrum, from radio waves to X-rays. The European Southern Observatory's Very Large Telescope, VLT, situated in the arid Atacama Desert of Chile, is playing an especially crucial role in this investigation. Its powerful suite of instruments is providing vital, high-resolution details. The comprehensive study documenting this black hole's awakening is led by Paula Sanchez-Saez. Claudio Ricci, another distinguished expert actively involved in the study of these cosmic phenomena, has shared his valuable perspective on this event. He emphasized that supermassive black holes, these veritable giant monsters that lurk at the hearts of galaxies, are typically found in a dormant state. For the vast majority of their existence, they are not actively consuming large amounts of matter and therefore not shining brightly across the cosmos. This general quiescence makes the observed awakening of Ansky in the galaxy SDSS 1335+0728 a particularly rare and exceptionally valuable observational opportunity for the scientific community, offering a live view of a usually hidden process. What profound lessons can we glean from carefully watching Ansky's ongoing transformation? This unique event offers scientists an unprecedented chance to study precisely how supermassive black holes turn on and ignite. We can meticulously observe the sequence of events as the black hole begins to draw in and accrete surrounding material. We can track how it subsequently starts to radiate vast amounts of energy outwards. Furthermore, this observation helps us to better understand the profound impact such awakenings have on the surrounding galactic environment. The immense output of energy and radiation from an AGN can significantly influence star formation rates and sculpt the distribution of gas within its host galaxy. The detailed scientific investigation of Ansky is, by no means, nearing its conclusion. In fact, it is just beginning. Astronomers have ambitious plans for extensive future observations. They intend to utilize some of the most advanced astronomical instruments currently available, and those soon to come online, to obtain an even clearer and more comprehensive picture of this reactivated black hole and its environs. The MUSE, Multi-Unit Spectroscopic Explorer instrument, mounted on the VLT, will provide highly detailed spectroscopic data. This data can reveal crucial information about the chemical composition, temperature, and motion of the gas swirling near the black hole. In the grand cosmic scheme, the awakening of the supermassive black hole in galaxy SDSS 1335+0728 represents a truly landmark event in astrophysics. It significantly enhances our collective understanding of these enigmatic and powerful cosmic giants. It vividly demonstrates that black holes are not merely static, unchanging objects, rather they possess dynamic and complex life cycles. They can and do transition between long periods of dormancy and shorter bursts of intense activity. Observing such a profound transformation in real time allows us to rigorously test and refine our intricate theories about black hole physics and overall galaxy evolution, reminding us of the universe's ever-active nature.